All right, this is going to be a breakout on object-oriented programming. This slide deck has objectives. I like them. Okay, describe what object-oriented programming is. Define property, method, constructor, class, instance, and prototype. Create a constructor function. Use this to refer to properties. And create prototype methods on constructors. These will kind of bleed into the other objectives that I have. Mainly, I wanted this slide deck for a quote from Steve Jobs. So the question is, what is object-oriented programming? This is from Mr. Steve Jobs. I'm going to read it to you, don't worry. Objects are like people. They're living, breathing things that have knowledge inside them about how to do things and have memory inside them so they can remember things. And rather than interacting with them at a very low level, you interact with them at a very high level of abstraction, like we're doing right here. He's in an interview or whatever. Here's an example. If I'm your laundry object, you can give me your dirty clothes and send me a message that says, "Can you get my clothes laundered, please?" I happen to know where the best laundry place in San Francisco is, and I speak English, and I have dollars in my pockets, so I go out and hail a taxi cab and tell the driver to take me to this place in San Francisco. I go get your clothes laundered. I jump back in the cab. I get back here. I give you your clean clothes and say, "Here are your clean clothes." Now, you have no idea how I did that. You have no knowledge of the laundry place. Maybe you speak French. Maybe you can't even hail a taxi. And maybe you can't pay for one, and you don't have dollars in your pocket. Yet, I know how to do all of that, and you didn't have to know any of it. All of that complexity was hidden inside of me, and we were able to interact at a very high level of abstraction. That's what objects are. They encapsulate complexity, and the interfaces to that complexity are high level. So in this case, in terms of OOP, we can think of the laundry object as Steve Jobs. We say, "Hey, laundry object, please launder my clothes." And then 20 minutes later, our promise resolves, and we get back some clean clothes. We didn't have to know what actually happened to launder those clothes. All of that is hidden inside of the laundry object. It's encapsulated. So that when we need something done, we just call a method, things happen, and we get back the result. And we don't have to worry about the implementation details. So OOP really is all about organizing your code and hiding details where necessary. Because if you had code that every time you laundered some clothes, you needed to drive to the laundromat, hail a taxi, drive to the laundromat, put money in the machine, wait 30 minutes, put it in the dryer, put money in that machine, get the laundry out, and then take that laundry back to where you came from. All of those steps, anytime you wanted to do that in your code, you'd have to write every single one of those steps. But if we take all of those steps, we put them inside of an object and throw them inside of a function called doLaundry, we are now object-oriented programmers. This is like a very, very high-level analogy for object-oriented programming, but that's the main idea. You're essentially representing the real world in code as objects. Everything is an object. The table is an object. The chairs are an object. These water bottles are an object. Laptops are an object. Humans are objects. All of these things have complexity, and we can start to nail down what it is that makes up that specific object. But object-oriented programming essentially takes a look at the real world and tries to implement that with code. Cool. This also breaks down into systems thinking. So how do you organize your code? How do we group parts of our application into parts that can be thought of as independent? How do we make reusable code that can be extended into more complex systems? So this idea of encapsulating complexity makes it so that as our code base gets larger, it's easier to maintain because we don't have code all over the place that's doing the same thing. We have method calls that kind of hide all of the details of what might be being done for that specific method. And this really also comes down to like application architecture. So like how do you structure your code in a way that makes it maintainable, that makes it clean, that makes it easy to work on and easy to read? All of these things are involved with object-oriented programming. And in terms of how do you make code reusable, we group related code together. So in this case, we put it into objects. We assign responsibilities to objects. So one of the tenets of object-oriented programming is an object does one thing and does it well, and it shouldn't do anything that isn't related to that object itself. So when you start to think like this, you can group your code into different objects so that you don't have one giant object with all of the application code. You have multiple objects that interact with each other. have objects keep track of their own state. If we think of, let's say, a to-do app represented with object-oriented programming, the to-do app might internally have an array of to-dos. It might have some methods like add to-do, mark done, mark to-do as done, remove to-do. But to the outside world, they don't have to know that all of the to-dos are stored in an array. They could be stored in something, we don't care. But our interaction with it is just through these methods. And the internal state is up to the implementation of the object. Define methods of interaction between objects. If we think about, let's say, a DMV. So a DMV has people working at the counter. A DMV has maybe a ticket machine that people walking in can grab a ticket to decide who's going to go next at the counter. But each one of these things might be a separate object. So I might actually have a ticket dispenser object that keeps track of what the next ticket I'll give out is. I might actually have a, what should I call it? The place where people are sitting.
A bench?
Bench? Well, sorry, the place where people that are working are sitting. Agents? Agents, right? Counter. Okay, let's create an object called counter. It has an array of agents. Each agent has a property that is busy or not busy or available or not available, something like that. Then we might have like the waiting room. That might have an array of people. And each person has a ticket that they got from the ticket dispenser
3 hours ago.
Yes, exactly. I realize right now all this is very abstract, but we could literally write the code that represents all of that and write the code to make those things interact. And don't let objects depend on the existence of each other. A lot of times in object-oriented programming, especially when you're new to it, you might create things that are totally dependent on each other. Like because you create these different classes and they're calling methods from other classes and you're passing classes into methods of other objects, essentially, those objects could not exist without each other. They're now dependent on each other. And typically, when we're designing a good system, we want to prevent that from happening. Am I done yet? No, stop it. Okay. That whirlwind tour of like what is object-oriented programming, some analogies thrown in there and stuff like that. If you haven't caught on by now, OOP stands for Object-Oriented Programming. One thing not mentioned in the slides is this is a programming paradigm. Is that how you spell paradigm? Cool. You don't have to write your code this way, but the people that came up with it have shown that when you do write your code this way, it makes it more maintainable. It makes it easier to work on, easy to collaborate on, easier to extend with new features. But it essentially is just a paradigm. It's a way of coding and a way of structuring your code. A way of coding and a way of structuring your code. JavaScript is technically an object-oriented programming language, but as a beginner, you don't have to know anything about that. You can write programs that don't use any custom objects of your own and literally are just a 10,000 line file of DOM interaction. It's totally valid to do that with JavaScript. But JavaScript also has built-in features for creating objects and structuring your code in that way. Other programming languages are object-oriented programming from the ground up. So like Java, C#, maybe C++. Those languages, you can only code in object-oriented programming with them. Java and C# have introduced new features for Lambda functions, which are essentially the ability to pass functions into other functions. In JavaScript, we take that for granted. We can do that all day, and it's super awesome and super fun. But in other languages, that's not built in. Because JavaScript is kind of on this weird spectrum, because in JavaScript, functions are first class. We can pass them around to other functions, like functions are values in JavaScript. And that is actually a functional programming aspect. So typically in functional programming languages, everything is a function. And you're just calling functions by passing in other functions, and it's just a chain of lots and lots of functions. Yeah. Kind of don't know where I'm going with this, but this first objective, define and describe OOP, I've said a lot of stuff. given all the stuff I've said, given the notes that I have up there, think about it to yourself. What is OOP? If your mom asked you right now to define and describe OOP, what would you say? Think about it.
Don't worry about it.
It sounds complicated. I hear that a lot.
And it's not. Keep thinking. I'm just going to talk. When I started programming, my first language in college was Java. So for me, programming from the beginning has been object-oriented. And so that's kind of I do think in object-oriented type solutions. For you all, it's been more of a, for the most part, kind of just imperative sequential programming model. You get the basics of programming, and if you want to make something happen, you might just write all the steps out that make it happen instead of organizing that into different objects that interact. And it really is just a new way of looking at your problem and deciding how you're going to solve it with OOP. Okay, you've thought about it, turn to a neighbor, define and describe OOP, use an analogy, come up with your own if possible. What is OOP?
Have different skills. This
All right, let's bring it back. Finish up your conversations. You hear the sound of my voice clap one time? Like sound of my voice clap one time? Thank you for your attention. Who would like to share what they talked about? Did you come up with? Were you raising your hand?
No. Waving.
Will.
So I was saying that it's a way of organizing and writing your code. So it is maintainable, readable, and efficient.
Maintainable, readable, and efficient. That's relative. Yeah, I'm not gonna put that. What do you say? A way of organizing what?
Code. Organizing and writing your code.
And writing code. Cool. Anybody come up with an analogy? What do you got?
I don't know if it's right, but it's sort of like how my phone is connected to a cord, which is connected to my computer, which is connected to the desk, and all these different things are objects, and they're all interfacing with each other, and they can get plugged in and interface with other things.
I like it. Pluggable. Honestly, though, that I'm thinking more of functional programming, because in functional programming, there's this idea of composition, where you have lots of small functions that do things well, and then you take those small functions and you compose them to make a larger system.
So how is that different than object-oriented programming?
That's what
Yeah. So let's just talk about that here. So there's this term for a lot of the FP people use, composition over inheritance. And actually, I think this might be a tenet in modern object-oriented programming too. Composition over inheritance. So one thing I haven't talked about in object-oriented programming is not only do you structure the world with objects, objects can be related. You can have some top-level class like animal, and that top-level class defines behavior that all animals have. So all animals speak, all animals can walk, all animals have, let's say, default to 4 legs. You can describe like the general behavior of an animal, but then you can define a class called dog that inherits from animals. So you can say class dog extends animal, and now by default your dog class has all of the built-in functionality of animal, but you can add on to it and you can override things. So you can say, well, when a dog speaks, it says wolf, and a dog actually has 4 legs. Different things like that, but all of the base functionality is defined in some parent class, and then your child class extends that functionality more specific to that class itself. These class hierarchies can be infinite. Like you can have this class which inherits from this class, which inherits from this class, which inherits from this class. And this tenet here is basically saying, instead of because a lot of times, if you're truly trying to use object-oriented programming and you do want to inherit some functionality, you might inherit from something even if it doesn't really meet all of the criteria of that thing. You're just inheriting from it because you know that some of the things may be used in this other class, and so then you might have some unused classes, or that actual inheritance may not mean what you actually think it means. Whereas composition would be you don't necessarily inherit from some other class, but you have functions available that you can use inside of your class instead of having to inherit from some other class. I don't know. Really, it's just 2 different ways of programming. And one thing about object-oriented programming is typically you're mutating state. Typically, an object will store information about its current state of being, and that state of being will be modified. In functional programming, you do not modify state. State is never modified. You might have seen this in React, where when you're setting state, it always has to be essentially a copy of the previous state. You're never overriding properties, or you shouldn't. You essentially create a brand new state that's a copy with the things changed that just got changed to represent the new state. Whereas in object-oriented programming, you just modify the state. In Vue.js, we just modify the state because it has change detection and stuff like that. So modifying state isn't always bad, but that's usually what you run into when you're talking about OOP versus FP.
I don't want to go down a rabbit hole.
What you got?
So give me sort of a definition of state in my mind. Because we throw this term around.
I think it means
see it everywhere.
It means what you think it means.
And I think so.
Give me your definition of state.
So it would just be like the existence of that thing as it is right then, like what that thing is in that moment.
Sure. I'll go to a to-do app example. The state of a to-do app would be the to-do items inside of the array. So like at this point in time, what is the data that represents that to-do app? So an array of objects that all have a title and an is-done property. Whether or not the to-do is marked as is-done or not, that's also state. Because with that data right there, we have a representation, a pure data representation of the application. It's not involving any UI or anything like that. It's like if we were to purely just think about this app in terms of data, what is the current, I don't want to use the word state, what is the current way of being of the data? And that very much translates to React. So like in React, you're building apps, they have state, which is what's the data behind these components. And then as the user interacts with the app, state starts to change to reflect how the user has interacted with the app. But at any given time, state is the way things are at that point in time. Yeah?
So are front-end frameworks, like by their nature, object-oriented or?
No, so like state can exist outside of object-oriented programming. That state is a more general programming term. React, technically you're using like OOP concepts because you're like extending from component. But React itself bills itself as like a functional reactive programming, where your components are essentially functions that return a view. Like their render function returns the view in terms of the state. And so every time the state changes, that render function runs again to produce a new view in terms of the latest state. So it's more functional, I would say, than object-oriented. But because it's JavaScript, you really can mix the concepts.
Is state a blanket term for all of the data within an application, or does each, like if I had an array of objects that had a bunch of key value pairs, and would each of those objects have state?
I would say it's for the whole application.
The whole thing?
Yeah, I mean,
Only one state.
you technically might break your state up into different pages of your app. And so like at the top level, all of the data for that page might be state. But really it's all of it. It's like, what is the current state of the whole thing?
Okay,
And that's including the small details of even like the smallest piece of data inside of your state.
cool.
Yeah. All right.
So then what differentiates OOP from functional programming is OOP seems to, the objects retain some state,
Right.
whereas the functions don't.
Right. And if you're writing pure functional programming, you have pure functions, meaning a function will not touch or modify any global variables. It takes in input and then returns some new output based on that input. And if it's a pure function, every time you call that function with the same input, you're always going to get back the same result. Cool. I just want to show some examples because we've been talking. This is a good conversation though. This is cool. It's cool stuff. I was gonna have you do some stuff, but I want to make all these words I've been saying make a little bit more sense. So I am going to model Galvanize using object-oriented programming. I'm going to use class syntax just so we can kind of see how this works. So I am first going to create a class called school. And the constructor will take in a name, and then we're just going to say this.name equals name. So the way to think about a class is this is like a blueprint for many different copies of a school. Because I could use this same blueprint for Galvanize, for Turing, for what's that place across the street? General Assembly, we work, yeah. But this one constructor function, I could use it multiple times, pass in different names, and I get new copies of the school that all meet this blueprint, which is an object that has a name. Let's say a school also takes in like programs. And so programs will be like an array of programs. I don't know. Right now, I'm not liking the fact that JavaScript doesn't have types because this doesn't make as much sense, but let's use it. Okay, so I have this class school. Let's create some instances of the class. So I'm going to create Galvanize. This is going to be a new school, and we pass in the name Galvanize. And the programs it has are WDI and DSI. So Web Development Immersive and DSI. But we could create another school. So let's create General Assembly, and I don't know what they have. Full stack losers. I don't know. But if we see how this thing is working, so right here I'm creating a variable called Galvanize that is an instance of a school. When I create this instance of a school, I'm saying that the name is going to be Galvanize, and the programs are going to be an array of strings that represent each one of the programs. So both cases here, Galvanize is an instance of school, General Assembly is an instance of school. Now, let's do some other things. So the school will also have a way to enroll a student. And under the hood, we're going to need some way to keep track of students that are out of school. But so to do that, this is like internal state of the school. So the school will have students, which will be just an array. It's going to be an array of student objects, or maybe even just student names. Yeah, we'll just do student names. So when I first create a school, students is totally empty. When we enroll, we will take the student that you pass in and push it into the student's array. Student. And now this is essentially modifying the internal state. So when I create Galvanize, if we log it out, it's just a simple object that has name, programs, and then an empty array of students. And if I log GA, same thing. So let's run this code. So when I log it, the first one is galvanize. Notice students is empty, and the second one is GA. Students are also empty. But now we can enroll students. So let's create another class.
If you didn't want to like edit the original state, if anyone said you want to make a copy.
That's functional programming. In OOP, I'd modify all day. So this is using this internal state and just adding something to that state. I'm going to keep moving. Okay, so I'm going to create a new class called student. A student has a first name and a last name. And then we're just going to set those properties on this instance. So anytime you see me using the this keyword, we're basically saying, because remember, a class is general. It's like a blueprint for it. And when we use this, we're referencing the instance. So later on, we're going to create instances, which we did here. And when we use this, we're referencing and modifying that. Break! Okay, so now I have another class called student. Its constructor takes in a first name and a last name, and then it just sets properties on the class itself for first name and last name. So let's do this. Down below, I'm going to create Greg. 1G? 2Gs?
What, you got it.
Cool.
Yeah, right.
So new student, Greg Paulos?
You got it. Paulos.
There you go. So I'm creating an instance of student that is Greg, and I'm going to enroll him in Galvanize. So I'm going to say galvanize.enroll, and I'm going to pass in Greg. So enroll is a method on my school object that allows me to pass in a student and then just adds it to the students array. So without looking at the actual class definitions, like this is object-oriented programming because we see how these objects are beginning to interact. So like I create an instance of school, I have a couple of schools, I create an instance of a student, I pass that student into the enroll function of Galvanize, which puts it into the internal state of the school itself. I could create some more students. Let's do Emily Pancake. That's your real last name? Is that your parents' last name too? Cool. So when we call enroll, it's modifying the internal state of the school to put that student in that school. Who's not in the room right now that we should enroll in GA? Let's enroll Kyle Coberly. I don't want to scroll. First name, Kyle. Last name, Coberly. So this is going to be Kyle, and we're going to enroll him in GA. Cool. Now, if we were to log out to Galvanize, we would see that the internal state of the school is now actually has 2 students, and if we log out GA, its internal state has 1 student. So this one is Galvanize. The students are Greg and Emily, and then this one is GA, and the student is Kyle. Cool. Question?
So I finished the 3 drills of OOP, and I'm just noticing a few things that I don't know if I did the wrong way. So for instance, when you have your constructor, I was just doing it like after school, passing in parameters there. So like name and programs and the brackets would be right next to school.
Right here?
So, I mean, is that like do a different way?
It might be a new syntax I haven't seen. Is
No,
that what
I have no idea.
is that what you're talking about? You did this?
Yeah, and then name and programs would be there, and there's no constructor.
Did you call it a class or a function?
Oh shit. Call it a function.
Yes. So I'll show the difference real quick, but the difference between the two.
Good one.
Yes. So when you're using class syntax, you must have a constructor function. I want to make this a little more interesting though. So we got our school, we have enrollments. Let's also have like cohorts. So we'll initialize cohorts as an empty array. And then we'll say like we'll say like add cohort. This takes in a cohort and pushes in a cohort. But then let's maybe also create a cohort class, and its constructor will take in, I guess, like the G number, right? Like G75 or whatever. And Yeah, so let's say this dot G number equals G number. Now it doesn't make sense to have GA, but regardless. And let's say a cohort also has students, because we have students for the entire school, but then we want students to be represented in each cohort, so we have them there too. So now down here, let's create an instance of G70. So G70 is going to be a new cohort with G70 as the G number. We'll also create G75. And then, so both Greg and Emily are enrolled in Galvanize, but they are enrolled in separate cohorts. So now that I have these cohorts, I actually want to, and I'm going to get rid of GA. Let's just use Galvanize. It makes more sense with object-oriented programming if you are reusing your objects for multiple purposes, but it still might make sense to structure my code in this way. And so now Galvanize has this add cohort function where I can pass in these cohorts and then like pass in G75. And then let's do this. So when we enroll a student, we also want to pass in the cohort. So that way, I don't have to directly modify the cohort. And now when you enroll a student, first they get pushed into the students of the school itself, and then we'll also say a cohort.addStudent, and then pass in the student there. And so now on cohort, I can create an addStudent function method that takes in a student and just pushes them into the students array. Students.push student. So now, whenever I enroll Greg, I need to pass in the G75 cohort. And when I enroll Emily, I need to pass in G70. And if we look, should work. Why not? So they don't, because notice how this method says cohort.addStudent. So I'm expecting. Oh, actually, sorry. This needs to be passed into the enroll, not the constructor function. Enroll Greg in G75, and then enroll Emily at Galvanize in G70. Because when I invoke enroll, I'm passing in the student and the cohort. So the student is just an object that gets pushed into the array. Cohort is the actual instance of a class that has the addStudent method, so that I can pass the student into that too. Cool. And now when I log Galvanize, it's going to be pretty complex. Whoa, that's not right. I'm pushing cohorts into the students array. That shouldn't happen. That should be pushed into the cohorts array. Okay. So this school has these two students. This school has two cohorts, G70 and G75. Each of those cohorts have a students array that reference some students from this array up here. When you're logging it out with Node, it doesn't, if it's very nested, it won't log that. But we could log galvanize.cohorts. And if we log just that, we'll see, let's log cohorts at 0. So we should see G70 and then the students in there right now are just Emily. Okay. I've kind of just been showing like this class syntax. We're seeing how this stuff interacts. You too can structure your code this way if you like. But let's talk about the specifics of what this is actually doing. So class syntax was introduced in ES 2015. It's essentially syntactic sugar. So we can use the class keyword to create these things, but this is no different than creating a constructor function and using prototypes, if you've seen that. So let's rewrite this thing using the old syntax. ES5. So the way this works is you simply just have a function with the name of your class, and that function itself is the constructor. So I can pass in name and programs. And then all of this code goes into that function there. And then these are known as method definitions. And instead of, well, technically I could put them on this, but to add them to this constructor, I use, what's that?
This one.
You can, but I'm going to show us the prototype. So you say school.prototype dot enroll equals a function that does this. And then same thing for add cohort. School.prototype.add cohort equals a function that does that. So this syntax here is doing exactly the same thing as this syntax here. It's just a new way of writing it. One thing about object-oriented programming in JavaScript is that it has prototypical inheritance, prototype inheritance. Whereas every other language ever invented uses what's called classical inheritance because it's not prototypal inheritance. There's some caveats to that. Look into prototypes and JavaScript. Google that. Just Google that. Look into it. It has certain implications for whenever you're inheriting from other classes, because essentially anything in the prototype chain that exists will be used, and it has some, maybe I'll say like unexpected behavior if you're used to classical inheritance. Yeah, but this is how you do it. The prototype you can think of like, because school itself is like the blueprint for a school, we're essentially putting this function on the blueprint so that it can be used by all the instances of the school. There's a difference between defining it like this versus defining it on the instance itself. So this is one way you'll see it. You might also see it this other way. Instead of defining it on the prototype, inside the constructor, you can say this dot enroll equals a function like that.
So which version is that?
What do you mean?
Is that a combination of like the old way and the like?
I'll expand. Yeah. Definitely. Well, no, this is add cohort. This behaves exactly the same way as this. The only difference is now every instance is going to have its own copy of the function. Because notice, we're defining this function inside of the constructor. So now every time this constructor gets called, we create essentially a copy of this function. And so every instance will then have the copy. Whereas if you put it on the prototype, all of the instances share the same function. But then when these functions are called, it binds the this to be the this of the instance. So this function will get bound to the this of an instance like galvanize. So when we call add cohort, in here, this function is bound to the this of that instance. So inside of here, when I say this.cohorts.push, we're pushing into galvanize.
It's like binding in React.
Exactly. But it does it under the hood when you create an instance of a class.
So the other way with the this dot, whatever you call that method, how does that?
I believe this will not bind the function, and this will actually break because this function gets its own this. And so to actually reference this inside of these functions, you have to do something like self equals this, and then inside these functions, do that. Or below it, you could write the code that binds the this to
So
this
if you
instance.
created a new instance of a school, then it would be getting all of that,
Yes.
those functions as well, which you probably don't.
Yes, it would.
Okay.
Each instance of a school would have a copy of the function. Did anybody count how many times I said this? Job, how many?
No.
Okay.
So, can you assign like if you wanted to do functional programming like you have it up right now, can you just assign like this dot student equals the name and then pass that into the function as a parameter itself? And instead of having to do self, and so that way that you can like individually track that within inside the object itself?
I don't know quite what you're asking. I think you're kind of on the right track, though. Essentially, but with functional programming, you would not have any sort of internal state. You might use, well, actually, I guess you might, but then you would use.
This is not functional.
This is not. This is object-oriented programming.
This is OOP using the function like constructor syntax.
Yes, but the thing is, just because we have functions doesn't mean it's not OOP. So technically, a function on a class is called a method, but it's still a function. It's still a block of code that can be run when we invoke it. But like in this case, these are called methods. They're still technically functions. So in OOP, you still have functions, but it's not pure functional programming. Cool. Yes, sir.
I have a question that is in a little bit of a different vein. So if I do all these constructor functions because I want to make a fetch, get a shit ton of data, and then like basically call these functions within a loop, is that still OOP? Like, so if I get like a massive block of data from an API call, I have all my constructors because I want to take that data and reformat it in a way to create new objects for each iteration through my loop. Is that OOP or is that just like a weird mashup of OOP?
I would say you could probably encapsulate and abstract it a bit more. So like when you're looping over the data, what are you actually doing? And you might extract what's happening inside of the loop into a function. And then that function might exist on some object, like an object called data formatter or something like that. Or you might have a class called data formatter that has a method called format data, where you pass in the array and then it spits back some formatted data. Yeah.
So like kind of but not really.
Yeah. And really that is JavaScript. Like JavaScript lets you do that. So that's why you would. We have reached our time. This has been an extremely low ratio lesson, but I appreciate you for listening and participating where necessary. I will Slack this code out. Any last comments or questions before we end this?
That was great, thank you.
You're welcome. Cool.